Aha. So progression, they didn't specify. So first term is 12. Okay, let's underline. Fifth term is 18. Find the sum of the first 25 terms if the progression is arithmetic. So two types of progression that is taught in the syllabus. Okay. One is called the arithmetic progression, or AP. So it basically signifies where you have A and then a common difference. First term is A and a common difference of D. That means you keep on adding D. When we say adding, it's just like, even if it's a negative, minus is just a adding actually of a negative number. So A plus 2D, blah, blah, blah. And then the nth term will be A plus, as you can see, is one less on the n there, nth term. So this is Tn. Nth term, A plus n minus 1D. This is T3, that means a 3 and 2. Can you see the pattern? 2, the coefficient of D just decreases. And every single term has that A there. So that is how we see the arithmetic progression in this case. Okay, now let's have a look. So they say if the thing is arithmetic, therefore the first term, so we're given, sometimes you don't know what to quote when you're solving a question, just write the word given, whenever it's given information. So T1 is 12. That means A is 12. This is just a shorthand for A is 12. And the fifth term, so T5 is equals to 18. So when you have T5 is 18, oh, that means A plus n minus 1. The n just replaced with 5. N minus 1D is going to be 18. So we just substitute this. I just do it loosely like that. And yes, you can write like this in the exam. They'll just look for keywords in the answer scheme. The answer scheme is always looking for keywords only. Numbers, whatever is written, they take it like that. So 12 plus, this is 4D equals to 18. Aha. So 12 plus 4D is 18 means now we solve for the value of D. So basically, usually, this is just what we say, a way to get the values of A and D. There are two information given at the start, will be always just a way to get the two things. So dividing that, and then you'll see that D is 3 over 2 in such a case. Let's put a bar here like that. Okay. So now they say, now we know the A and D values. So I'm just going to put a box around it so it's easier for us to capture those values and use it on the second part. So A is here and the D is here. Oh, find the sum of, they say, the first 25 terms. Find the sum of the first 25 terms means now we need another formula, which I haven't given yet. So you see the nth term there, the nth term formula up here. Aha. So the formula for the sum of first n terms. Okay, the first n terms of an arithmetic progression means we normally denote it with the shorthand or symbol as n, sum of the n terms, as for sum, T for term. You can say all this are easier to think. So let's use the most classical one, the most broadest definition. N over 2 like that. 2a plus n minus 1b. Okay, this is the meaning of the formula to use. So that means the exam style of learning, sometimes you don't need to understand everything. Do I go a lot of details? You must understand the exam style of learning. We can just remember formulas, use keywords, match it up and solve. A lot of students do that actually. Not say a lot, maybe some students do that. And they still do get the marks regardless, you know. So that's how they learn for the exam. So that's another strategy. This purpose is different. Of course, good to understand as much as we can. And then there's another thing I must mention here. How does the Tn and Sn relate? Because sometimes they may write in some weird ways, especially when it's A levels or other things. So they sometimes find creative ways of making new questions. So that is why I write things like this. T1 plus T2 until this is Sn. So we never know how they can give this notation. So this is the link, how it looks visually. Okay, being that said now, all we need to do now is sum of the first 25 terms. So when we relate it here now, the formula and the context, the n is 25. Oh, that means the S25. Sum of the first 25 terms, I just replace the n as 25. So 25 over 2, then the bracket is 2a. A is what? The first term is 12. And then n minus 1, so 25 minus 1, d. D is what? D is the difference, common difference, 3 over 2. How am I getting those two numbers? You'll be wondering. This 12 comes from here. Where does the D comes from? down here. Oh, so basically I'm just using this formula at this step by substituting those values of A and D respectively. And we can now compute a bit more easily the next line. S25 equals to 25 over 2, blah, blah, blah. Okay, this whole thing is just a number. So maybe I'll simplify a bit just to show 24 plus 24 over 2, short times 3 is 36. Okay, then just put in the calculator, please. Okay, easy to key in like this when it's mostly numbers like that, when you got the bracket and all that. All right, Craig, just in case I calculate wrong, just let me know if in case plus 36 and then divide by 2 and then times that. Okay, so the answer I think should be 750. Okay, please take note 750. Done. So this is the first part. 4-1, question 4-1. Huh? So I'm just going to save this and let you all know. Wait now, 1 minute please. 4-1. Okay, this clear for a while. So we're going to save this and back to the question. Okay, the next one. So we're going to go for question 4-2, please. Now let's read and see. Find the 13th term if the progression is geometrically same. Aha. So the if part is kind of like cool a bit because it has the arithmetic, and now they're asking it is if it is geometric from the same wording. Usually they don't really do this in maths, but A levels look like they're doing it. Okay, the fifth term is this, right? That means we can still first we must understand what is the geometric progression. They're using an adjective here, so using the noun as geometric progression. This is called the geometric progression, and just call it GP. So we have an A here, the first term. So A is going to denote the first term. I'll write it after this, and then A times R. We multiply a common ratio AR square. Just like plus was the opposite of divide, plus and minus was the same thing as adding a negative number. So divide and times are like paired like that. So times, like for example, dividing by 2 is times half. Dividing by 3 is times 1 over 3. So we don't need to take a special consideration like that. We can just take it as R times R. The ratio can be 1 over 2 or 2 according to whether it is divide 2 or multiply by 2 respectively. So the nth term will be something like this. So I'm just going to denote below it the T1, T2 thing. So we get a bit more better at this, hopefully. T3, T4, as you can see the pattern, that's why I wrote n minus 1. Because each time you see the, like for example, the 4 here, this is 1 less. 3, 2. This is what I meant even the earlier one. Huh? So n minus 1. Okay, now being that said, what is this meaning of A and R? So A is actually, there's one more thing I want to write, sorry. Missed that slightly. This is times R. You can see that each time we multiply by a common ratio, that means it's like increasing AR square algebraically. So good to think at this level algebraically, because when you write algebraically, you are solving a whole class of problems and not just a particular problem. That's why they do these notations and all that. Okay. So let's go for A. So the A is called the first term. Okay. Oh, this is the first term. Huh? And then R is the common ratio. Please take note. R is the common ratio. Okay. So these are the definitions that are what we say sensitive to the geometric progression. Okay. GP or geometric progression. So the reason that means every branch of maths or even subtopics have its own jargons or sensitive terms. So when you know them, there's a reason why. Let me just like be defined on the 2 parameters, the first term and the common ratio only. So the nth term is this one, as you can see here. I did it visually. It's the nth term. Oh, so they say find the 13th term. That's all. So we just need to use this formula. So if I have to rewrite it, sometimes I'm writing it double, makes it a bit more clear. So Tn, or the term n, nth term, is AR n minus 1. So we just need to substitute. Oh yeah, before I can do that, then I realize I don't have the A and the R. That means now we need to use the originals. So from here we bring the original terms. So the first term is 12. So that's quite straightforward. The A is 12. And then from here, this is one. This is the 5th term. So the 5th term means T5. T5 is 18. Aha. So I'm just going to substitute the formula here the formula you see there. That means, so it becomes AR. Oh, it's 5 means 5 minus 1, right? Equals to 18. So I just substitute out the A. So this becomes 12, as you can see. This is R to the power of 4. And then this is 18. Okay, so no worries. Let's have a look at what is R. Then, so it becomes 18 over 12. Out of the power of 4 is 18 over 12. So it didn't really quite turn out to be such a nice number after all. So this is divided by, sorry, I can divide by 6 times 3, 6 times 2, 3 over 2. Okay, this is the thing about these kind of questions. It's not always nice numbers. So from here we can deduce that. I just put a comma here. R is the 4th root of 3 over 2. Okay, it's kind of hard to write that. So I'm just going to write 1.5 better and put power of 1 over 4. Because 3 over 2 is 1.5, huh? Bit easier to write. Okay, not an issue at all. So sometimes we can do shortcut. Instead of doing that, now you can see why. Because you can just keep it as R to the power of 4 as 3 over 2. Let's keep it like that. The reason why I'm writing like that and still contemplating, because then I realized they asked a very nice number. 13 doesn't look like a nice number, but due to the formula, it's going to be something nice. 13th term means we select the n is 13. That's the meaning of the 13th term, huh? And therefore, we write T13 equals to AR. Please just substitute that. If you find it hard, you can do slowly like that. If not, you can just go ahead as usual. So there's no real reason to write the left-hand side. So AR 12. So this is why I didn't write that, because I wanted to show the small shortcut here in the corner here. Let's say we just need to multiply the powers by 3. You can think even the power like as though like what you do to the left, you do to the right, or you can think of it like raising it to the power of 3. Same meaning, yeah, by the way. Just mentioning it differently. Okay, 3 to the power of is already a power 1. That means we're going to think of it in times, huh? Power level just to the times now. Oh, it's how the law of algebra is. So they define all these laws prior. So R to the power of 12 just became 3 over 2 to the power of 3. So it's just another friendly number, which is 27 over 8. Please take note. It's 27 over 8. Huh? Okay, now, being that said, the 12 there and the 27 over 8, huh? Back to power of 12. So we substitute. So let's substitute, please. Let's then go here. Okay, so the A I take from here. Put an arrow from there to show wherever this is used. That's what the arrow denotes. Let's write the same color. This one is 12, right? Let's write a golden color, that one. The one I wrote, that one, R to the power of 12 is the green number, 27 over 8. Oh, so how this is how it all adds up. And we're ready for the answer now. So just put in the calculator, please, and hit the fraction button if it's still a fraction. Let's see whether it's such. It is. And going to put a fraction, preferably when it's a decimal. Yes, let's just put it like this. 12 times 27 over 8 is 40.5. So the 13th term, if it is a geometric progression, it would be 40.5.